Howdy everybody, welcome back to Lab Hours. Today is going to be the example lecture for Nice to Sheet You, which is the Excel lecture that I wrote as the first of 3 lectures in the Excel Stata lecture block for Econ 378 Statistics for Economists at BYU. This lecture series, the 1 through 3, is supposed to sort of introduce the tools that we use for processing and recording data as economists, and to sort of get the students who may or may not have any experience in any of these programs at all sort of acquainted with these tools so that they can use them for assignments and for the data project that currently is a part of the course. So lecture notes for this that I have written up are linked in the description, as well as all of the other resources you would need for the homework that accompanies this lecture. The lecture notes are in PDF form. They're also in LaTeX at the GitHub link, which I will have in the description. And of course, if you have any questions, you go ahead, email labhours@tmorg.org. I'll get an answer to you, or just leave it in the comments, I'll answer those too. So let's get right into it. I'm going to be looking off to the left here because this is where I've got the lecture notes kept, because I do have this desktop up here to show you sort of what this would look like if I were doing this as a lecture. So that's where I'll be looking. It will look like I'm looking at the screen over here, but really I'm just looking over here at my iPad. So the one thing we need to make a note about for these lectures really quick is that we want you to not have the students try to follow along with them. So you can actually do until the third lecture. So the idea is for these first 2 lectures, Nice to Sheet You, the Excel one, and A Blind Date with Big Data, which is the first Stata lecture, you could do those in any classroom because we don't actually want the students to be following along on a computer for these. I have found that as I've observed people teaching Stata and Excel lectures for 378, that most people just sort of get behind, or they get lost, or they come into class late. And so they spend time trying to catch up to where we are, but they've missed all the introductory parts, so they actually don't have the skills they need to do stuff, and it's just a conundrum. So my recommendation is, while you're actually teaching, don't try to have any of the students follow along or anything like that. The exception is the second Stata lecture, the third lecture in the series, is designed to be about half length, so that you can take the back half of that class and have them in a computer lab and have them start the second assignment, because in that second Stata assignment, they're actually going to be writing their own code, whereas in these first 2 assignments that correspond to the Excel and the first Stata lecture, it's a lot more hand-holdy. Okay, so all of that in mind, and that is also on the lecture teaching notes that are linked there, in case you forget. I think it's pretty important, because they actually need to see what the principles are, which is like, we write stuff for the computer to do and it does it, but we have to write it a certain way or the computer doesn't know what to do, right? So let's go ahead and jump right into the actual lecture now. So first thing we're going to do, and again, this is just sort of a very basic overview. I'm sure you'll be able to fill in. I got to sneeze really quick, sorry. Oh, come on. Oh, man. Thank you. Bless me, I guess, right? Let's pull up Excel. And of course, this is going to be fairly bare bones. I mean, the lecture notes are kind of bare bones for the Excel one, because one of my hidden purposes in these set of lectures is to kind of propagandize Stata a little bit, because I like Stata more than Excel, and it's good to get them these skills before they get into 388 or their more advanced classes if you're not actually using this at BYU, right? So let's go ahead, get it up, and how I would start the class is we'd be talking about, we're going to use Excel here, and we're just going to open it up. And you can do all the same things in Google Sheets, because the commands are actually the same. And I personally find Google Sheets a little bit more accessible, but we'll do this in Excel. It's practically exactly the same thing. So we open up Excel. That's a great time, and what we want to do is we're going to assume that you have a classroom of at least 15 students. So you just go through, and everybody who's comfortable with it, you ask them for their age, their birth order, which is like what number in the family are they? Like, I'm the first child, right? Are you the 7th child, for example? And then just like the total number of kids in their family, right? So let's come over here and we'll say age, order, and number of kids, right? And so let's just say, for example, I'm just going to throw in a bunch of numbers here that like look reasonable for like college kids, Maybe we got some young ones in here. Maybe we got one oldie. But then most of them, because this is kind of an introductory class, are like early 20s, late teens, right? I've got 18 of them there, and then I'm just gonna go like this. I'll fix those in a second, don't worry. Let's make that a firstborn, and then let's make that a firstborn as well. And then number of kids in the family, we've got 1, we've got 3, we've got 3, we've got 6, we've got 2, we've got 2, we've got, I don't know, 6, we've got 4, we've got 8, we've got 9, we've got 3, we've got 4, we have, I don't know, we're just making this up, right? Making up some data, you know how it goes. Every once in a while, we're pretending that we're actually getting these from the real students, right? And let's say they have 10 kids. These are big families. I mean, this is from BYU, so that's a whole thing. But you will find numbers that look slightly different from this. The actual numbers don't really matter that much, right? So now that we've actually gone through and gathered the information, which will take you presumably much longer than this, but not too much longer, right? You'll just go down the line, and whoever's comfortable will actually share it, right? So now we're going to introduce the idea of an Excel function, which is to say, now that we have all these numbers recorded in these cells, we can call those cells using functions. And functions in Excel come from the equals sign. We can do simple math things, like, for example, I can just subtract your age from the current year to tell me what year you were born, potentially. So let's call this birth year. And this won't be exactly accurate because of like months and dates of birth, of course, but this is going to allow us to introduce the idea of a function. So the current year for me is 2022, so let's do birth year is equal to 2022 minus however old they are. And all I'm going to do is I'm going to click the cell in this row, which is an observation, and then I'm going to pull it down with the fun little trick that we're going to show to the students, right? But it's like, oh, look, if you're 21 in 2022, you were probably born in 2001, which is crazy, but that's okay. And then, so we notice that this function here is calling the specific value in the cell. And if, for example, I hit enter, that's great. If I change what's in cell A2 and make it 22, this function automatically updates, right? And that would be something I would show them. That's not actually like listed here, but I think it's fun to play around with, right? So let's change this back to 21 just for fun. And then one other thing to show is you could come down here and you could hit equals 2022 minus and then click that cell right there. But the really fun thing to notice is that Excel has this nice little block down here in the bottom right corner, and Google Sheets has something similar, to where if I just take that and I pull it all the way down the row, all the way down the column that I want to fill in birth years with, it will actually take the formula that I've written, right, minus A2, and then it will actually just increase the cell to stay in the same row, or the same relative position, right? So this cell right here calls A2, which is over here, right? It's 4 cells to the left. If I had had this cell call A1, then pulled that formula down throughout this row, throughout this column, then this cell would call A2, right? So if this one called A1, it would be calling the cell 1, 2, 3, 4 to the left and 1 up, right? So this one would call 1, 2, 3, 4 and then 1 up, right? 4 to the left, 1 up. And that would have happened for all of these. But that's cool because Excel lets us use a shortcut like that, which is we don't have to go through and actually type equals 2022 minus A10 for this age one right here, right? Super cool stuff. Very nice, very useful for while we're using Excel. And so you can see we've got approximate birth years for everybody listed here, which is great stuff. Now what we're going to do is we're going to move away from just the numbered functions, right, which is just I'm just doing a subtraction problem, right? Excel can also be smarter than this. Oh, that's one thing I don't like about Excel is that it doesn't know when I'm trying to just click away. So that is a nice thing about Excel is that it can do simple math for us, right? But this is something we could have easily done by hand, right? Let's say, for example, instead, let's do things like minimums, maximums, averages. Let's do some summary statistics on this data set. For example, let's take a look at this age variable that we've got over here, and let's find the minimum Let's find the maximum. And I mean, this is easy to do by like eyesight for minimum and maximum, but let's also find the average. Let's find the median age value, and let's find the standard deviation of age in our sample. And I'm just going to adjust this column here. This might be a helpful thing to show, is that you can adjust column size, or you can actually just double click the column border and it will auto adjust for you. That's a fun thing that you can show and use if you'd like. We're going to use 5 Excel functions here, and I have them listed in the lecture notes, but what we're going to do is we're going to introduce this idea of, instead of just doing a number function, 2022 minus A2 minus a number value, now we're going to have Excel actually do some work for us. So I'm going to do equals here, and then you'll notice over here I have this drop-down menu. It's got some pretty common functions over here, and then we have a list of more functions. This is pretty much a list of every Excel function that you'll ever really need, especially for these purposes. But the other really nice thing is that, guess what? The functions are fairly intuitive. If I call, for example, equals minimum, and I start to spell it, I see, oh look, here's the min function. Returns the smallest number in a set of values, ignores logical values and text. Well, that's perfect, because that's going to give us the smallest number in our set of age, or the minimum age, right? So we do that. We hit I hit enter. That's my bad. These functions you can capitalize. You can leave them uncapitalized. It doesn't really matter. But the way that you call a function with these parameters is I put the word down, right? Equals the word, in this case min, from this drop down that came down here. And I'm going to call a parentheses here. And then it's actually going to give me a helpful little thing to fill out the format. You can do min of a set of numbers, right? I could do 3, 4, 5, 6, 7. And you can see that this little helpful little format thing is actually going to expand, and it's clickable, which is to say it will actually take me to the thing and highlight it, which is nice. And it will keep telling me things that I can fill in. But that's not super helpful. What I really want to do is I want to get this range of ages, and would you look at that, if I just click and drag, Excel interprets this A2 colon A18, and it interprets that as the range of cells, every value that's in the cells, from A2 to A18. So it's looking at 21, 24, 25, 26 when I do that column. The column implies a range. And if I were to expand that, for example, to B18, now we're also looking at order, because we're going from A2 in the top left to B18 in the bottom right. It's going everywhere from A to B, everywhere from 2 to 18, which is pretty nice. But we only want that A18 right now. So this min function, it's not including numbers here like Excel wants us to, except that when I tell Excel to look at this range, it is actually going to go in and fill those 17 numbers in, which is going to be super nice. So I'll close the parentheses and hit enter, and it tells me the youngest person in the class is 18. Now that's pretty easy for us to tell just looking at this, but if I had 100,000 students, I could actually just highlight the whole column and it would tell me. I wouldn't have to go looking, which is very nice, right? Let's see if we can't figure out what to do with maximum. I'm going to hit equals max, and would you look at that? It shows up right there. I think I have a space there. Never mind. Equals max. It shows up in the drop-down menu. Returns the largest value in a set of values. Super helpful. Let's do exactly the same thing. Just click and highlight the range, or we could have just typed A2 colon A18. Same exact thing. Oldest student in the class is 30. Again, very easy to see. But it's not easy to calculate something like average or mean. And in fact, I should have written mean here to hide, if I hit equals mean, these actually aren't functions that will do that. Like returns the geometric mean of an array. This isn't like normally what we'd want to do. This is probably more complicated than something that we would want. But another word for mean is like average. And boom, returns the average arithmetic mean of its arguments, right? So let's do equals average. And then again, same thing. I'm going to type it this time, A2 colon A18. And you can actually see that Excel is going over and highlighting those boxes for me as I'm typing that in, which is super nice. Okay. Average age in the class, 22 years and a little bit more than that. So fairly old class for college, or fairly young if you're at BYU, but that's a whole other thing. The median, this one is just median. And we're just doing this as repetition to sort of cement the idea of equals. a function and then what that function takes as an argument, or what that function takes as like its things you need to put into it, basically. So the age array again, A2, A18, and one nice thing is that like the caps on the letters don't matter. As you can see, I have a lowercase a here, but it still has highlighted A2 to A18, which is super nice. Median age is 21, that's pretty interesting. And then the standard deviation age, we're going to use equals stdev.s because this is a sample of all the students that could potentially exist. You can use stdev.p if you want. I personally don't want to, like, you know, if you've already done standard deviations in the curriculum and like you haven't introduced the idea of population versus sample yet for like S as opposed to sigma, go ahead and just use whichever you want and promise them you'll talk about it later and it's probably fine. Again, I'm going to type A2 to A18 here. Both lowercase this time, doesn't matter. And it looks like the standard deviation of age is 3.17. Pretty cool stuff. So we've found summary statistics. We've recorded statistics, recorded data. We've calculated one new variable. We've got some summary statistics. That's great stuff. Now, let's do a little bit more meaty work. Let's find like a correlation, right? Let's find the correlation. Hopefully by the time that you're doing this lecture, you've taught them like how to find correlation by hand, right? Like this is ideally coming after you've taught them about how to find mean, how to find standard deviation, what a standard deviation is, how to find variance, how to calculate correlation from standard deviations and covariances and stuff like that, right? So we know this is coming after that. That's fine. So we are going to go ahead and find the correlation. Let's something like between age and year of birth. And then maybe if the lights don't fade on me, which they did, so let me just pull that up really quick. So then maybe we can say, hey, does anybody want to try to take a wild guess as to what this number is going to be? And if they guess -1, I think they're going to be right. So let's just find the correlation between age and birth year. Let's do that. What does the command look like? Well, my guess is that it's going to start with correlation, and look at that. Correl returns the correlation coefficient between two data sets. Perfect. And it says it needs array 1 and array 2 as its arguments, separated by a comma. Now, what is an array? Well, the nice thing is an array is just that block of cells, right, that Excel has been highlighting. So my first array in this case would be the age array, which is A2 to A18. The other interesting thing you can do, I believe, A2 to A18, comma, that's my first array. It's highlighted in blue, the text is blue, which is nice. And then the second one would be the same thing, A2 to A18, except this one is in the E column. So I'm going to do E2 to E18, right? And so now I have my two arrays. Excel is telling me I have right here, age, birth year, good stuff. They're in there, and it should give me a correlation of -1, and it does. Now, why does it give me a correlation of -1? If you want to point this out to your class, it's because you're taking your age value and you're putting a negative on it when you're calculating this value. So, of course, it's going to be exactly opposite. You're just taking age, making it negative. Pretty cool stuff, right? But you might have been able to guess that just from looking at it, of course. So maybe let's use Excel to find a correlation that is maybe less obvious, but that could be, still probably pretty high. Like maybe the correlation between the number of kids in your family and your birth order, right? You would expect that people who were born 8th in their family would probably have a pretty high, number of kids in their family. But maybe somebody who's born first could have a high or a low number, right? So let's find that out. Let's do equals Corel again. And then the first array, I want birth order as my first array, and then I'm going to hit a comma, and this is me just demonstrating instead of actually typing the range. This time I'm just click and dragging the range, which is great. And now we're in blue and red again. I've got my two arrays, and this is the correlation between birth order and the number of kids in your family. And in this case, with the data I made up, it is very strong still. 75% correlation coefficient is pretty crazy strong, which makes a little bit of sense. And now maybe we want to find another correlation just for fun of something that we don't really have any good idea about. Maybe the correlation between age and, I don't know, what did I have in the lecture notes? Age and birth order, right? So again, this is going to be another correlation command, and I want to do age, and then separate it again by the comma. I'm just following the syntax that Excel gives me down here in this little hint, and if it doesn't show up, that's a little unfortunate, but it also, I believe it shows up somewhere up here for Google Sheets, so keep that in mind. Just test it out before you do the actual lecture, right? Make sure your stuff works. That's pretty standard convention, right? We all know how to do that, I think. Just test your stuff, right? And so let's see, age and birth order is what I said in the lecture notes, which I think is pretty nifty. And again, you can swap these for any numeric variables that you want to ask the class about, just like maybe number of credit hours they're taking this semester or something like that. You can play around with it. This is just what we came up with here that I'm using for the lecture notes. It's general principles, right? And that correlation is actually negative, which is pretty interesting. So the older you are, the older you are, the more likely you are to be born first or second or so on, which actually does make sense, I guess. Again, this is made up data though, so it'll be interesting to take a look at that and sort of describe and discuss what it means with your class. That will take some time, right? Because you will have just ideally learned about what correlation is. So that will take up more of your time, which is great because this lecture that I'm doing, this video right now, is not going to be the full hour 15 that you might expect to give in a class like this as a single lecture. So now that we've done some correlations, let's talk about doing some things that are a little bit more complicated. Let's take something like a conditional mean, which maybe you've already done or maybe you're not going to do until after this block of lecture, but hopefully you will have done it before. So let's take the conditional mean of age if there's more than 4 kids in the family, for example. And again, you can adjust this for whatever makes sense. Like if there's more than 3 kids in the family, or if they're taking more than 12 credit hours or something like that, right? So, and we can say, okay, one thing to point out is that on the assignment that I have written for this, I give them all of the commands. And so if you want to like pretend not to know this command and have to go like Google how to do this Excel to sort of teach them that idea and that skill, I'd say go ahead. But in my opinion, like it's much more important to know how to do that for stuff like Stata. And we're going to teach them a fair amount of that in the Stata lectures anyway. So for now, if you just want to teach them sort of the mechanics of Excel, up to you. I personally am going to err towards just the mechanics side. So we'll do something like average if, which is, the given condition or criteria. And now what I'm going to do is I'm going to point out again the syntax that it's giving me for Excel. And pointing out syntax and being correct with syntax is actually going to help them when they get to Stata 1, Stata 2, because they will find that the syntax is not very forgiving in those ones, right? And it's also not forgiving in Excel, but it's a little bit easier to deal with because you just have to modify one cell as opposed to like your command line being a whole thing, right? So the range, average if, range, criteria, average range. So the cool thing is, if I don't actually know what any of this means, I can actually just Google average if, right? So one thing, this is actually helpful sometimes, I think. Let's just do Excel average if, right? Maybe I don't know, for example, what it means when it wants range, criteria, average range. Well, I can Google it, and the Excel documentation is quite good. Syntax, average if. The average if function syntax has the following argument. Range, 1 or more cells to average, including numbers or names. Criteria, required. The criteria in the form of a number, expression, cell reference, text that applies. Criteria can expressed as like 32, the string 32, greater than 32, apples. Like if it's an expression, it has to be a string in this case. This is a good place to introduce the idea of the string, although we will talk about that more in Stata 1, so it's not super necessary here. Again, this is just sort of filling in puzzle pieces of syntax, which is sort of the idea behind the Excel lecture, in my opinion. And then average range is optional, right? The actual set of cells to average. So what I get from that, I mean, I already know how to do it, but you can sort of guess from this, if average range is the actual set of cells to average, then range is probably going to be the thing that it checks criteria against, right? And all sorts of this little help thing here, which is pretty nice. So let's come back over to Excel. The range is not actually what I want to take the average of. Remember, I'm trying to take the average age if the number of kids in the family is greater than 4. So the range I need to look at here and check against the criteria is actually the number of kids in the family. So that's this range right here, this array. The criteria in this case is that it is greater than 4, right? And then the average range, I actually want to average age as opposed to number. And when I hit enter here, it tells me, you know, the average age for the class is 22. But if you only look at the people who have more than 4 kids in their family, so 5 or greater, their average age is actually 20 and whatever that is, 5/8, looks like, something close to that. Yeah, 20 and 5/8, which is pretty cool, right? You can do conditional means like that. And if I were to change this to say greater than 5, it will give me the same number, which is pretty cool. But if I were to do it greater than 6, it changes the number, right? And if I were to do just greater than, for people who have siblings, for example, again, it's a different number here, which is pretty cool. Good stuff. And that's sort of, you know, what do I say here? The function, which can go in any nearby cell, is this function. Compare this conditional mean of age to the original mean of age. Take the opportunity to teach what a logical expression is and how they're used here. So the logical expression here is this greater than 4. So what it's doing is it's saying, take all the values of age that line up with a value of number that is greater than 4. If this statement, the number is greater than 4 in range, is true, then the corresponding value from 2 to 18, the age variable, is used. If this logical statement, this greater than 4, is not true for the C value, the number of kids in the family, then the corresponding A value is not used, which is pretty cool. All right, and if you wanted to show them like a more specific example, you might avoid doing what I'm doing there and forgetting to hit enter before clicking on other cells. And you might do something like this, right? You might just say 1, 2, 3, 4, and then you could do a 1, 1, 0, 0, and then you could do an equals average if you really wanted to get in on the logical functions, which again, we will touch on again in Stata 1 and talk about in Stata 2. So let's say I wanted to average this first column if the second column is a 1, for example. So the first column that we need to check, we're checking against the 1s and 0s column. The criteria, I mean, in this case could just be is greater than 0, right? Because it's either 1 or 0. You could also do like is defined as 1 there, but I don't want to talk about that one yet. We'll talk about that more in Stata 1, right? And then we wanted to actually average this one, this range right here. And, you know, let's just turn it into J10 to J13. That shouldn't actually change anything, but just to keep it nice and safe, right? The average is 1.5, and we can pretty clearly see, right, you know, the average of 1 and 2 is 1.5, right? So this value over here is only being used if this corresponding value over here meets the logical statement that is the criteria, right? In this case, is greater than 0, true or false. So that's a helpful one. If you need to really explain that one, you can do another simple little example like that. Pretty easy. But now we want to actually talk about one of what I think are one of the strengths of Excel, which is its graphs and its plots, right? And again, I'm not going to take too much time on this one. I believe on the assignment, it only asks for a histogram, but it may actually ask for another graph of another. I can't remember, but it is one nice thing to show, and it will take up class time, which is nice. So if we come over here and maybe say we want to plot, let's see, what could be an interesting plot here? Let's do like a scatter plot of like year and I have it right here. I have it right here in the I have it right here in the lecture notes. I'll just check the lecture notes, right? Highlight the year and family size columns. Demonstrate the control-click and shift-click shortcuts. You can choose to do this if you want, but basically this is true for a lot of places in the computer world. If you click somewhere and then click somewhere else while holding shift, I'm holding shift right now, it will highlight everything in between the two clicks. And then if I hold command or control on Windows, command on Mac, and in this case I actually need to hold control because I'm remote desktoping from a Mac to Windows. So I want to highlight birth year and family size. So that would be number of kids in the family. Take this time to demonstrate control click. So if I hold control click, it will keep the other thing highlighted while I also drag over that one, which is super nice. You can choose to show that if you want or not. I mean, you kind of have to with the control one unless you put these two variables next to each other. So after we highlight our two columns of interest, our two numbers of interest, we can go to the Insert tab up here at the top, and I have listed to do a scatter plot, which would be this one right here. This is a scatter plot, an X, Y, or a bubble chart. You can play around with a bunch of stuff. I'm just going to do it like this, chart title, and you can see it's actually gone backwards, right? It's got year of birth on the left axis and like family size on the right. This may not necessarily be something you would want, but I have listed here, play around with axis titles, colors, etc., right? You can do this as much or as little as you want. You could make bar graphs, charts, but basically the idea is highlight your variables, insert blank, or you can also do, if I just delete this really quick, if I go to insert and I do a scatter plot here, it will just go to the nearest thing, which is really interesting stuff. It's not always necessarily super helpful, but over here in this little funnel thing, you can actually select data. And you can swap around like the range of the data that you're actually looking at. These dollar signs just tell Excel to hold it constant so that if you move the graph or move the cell, it will not adjust like to the position like it did with birth year. So just like really quickly, over here in birth year, if this says minus A6, but I actually gave it like a dollar sign on both of these, and if I were to pull this down, it would actually turn everything there into 1999 because all of these would say A6 as opposed to updating to like 9, 10, 11 like it did before. So let me just undo that for you really quick. But yeah, so I'm not going to show you too much about how to like do graphs and stuff in Excel other than to show you, you do insert and you can select data from down there. You can put in the ranges. This is sheet 1. So when you go to select data, like switch row column, do the things, all sorts of stuff like that. Sheet 1, exclamation point, the range is how you officially call an array in Excel, like its full name of the range, right? So this one, if I wanted age, for example, would be, and I can actually just do A2, A18, and it would work, right? And it'll, you know, give me a different thing. Super cool. I don't exactly remember what it's got on the bottom here. On the bottom, it looks like it's actually just which row is it in, which is kind of funny. But you can mess with titles, age, by order of answer, and so on and so forth. You can play with, I'm going to leave that to you, how in detail, how much time you want to fill, how much time you actually have. You can also recommend just like looking up tutorials for specific graphs online because everything is online, right? So there's that for graphs. There's lots of options for graph types, of course. You can point that out. Line graphs, bar graphs, they're going to want to pick based on what best fits their data, of course, obviously. And then the one important thing that I would like to show is that there are data packs in Excel. There is one specific data pack that is very helpful to us, which is called the Analysis Tool Pack. That will allow them to do like regressions and stuff once they know what that is. But I want to show how to make a histogram, which is basically just showing how often a value shows up. You know that, you're the teacher. If you're a student looking at this as review, that's what a histogram is, and you're about to see one. Excel does not come preloaded with the ability to do some of these things like that, which is one of the things that makes it inferior to things like Stata, for example. But if you would like to load it in, people have built it. So we're going to go to File. We're going to go down here to Options. We're going to go to Add-ins over here on the left. And then we're going to go to the, when it loads, the Analysis Tool Pack, which is pretty cool. It's pretty nice. We're going to hit Analysis Tool Pack plus Go. Go. Analysis Tool Pack, OK. And now, what is really nice is that in the Data tab, there used to not be this tab here, this analysis thing. And I really should have shown you before I threw the... that would have been helpful, I think. But basically, in Excel specifically, it will add in this data pack. I believe in Google Sheets it comes preloaded, but I'm not 100% sure. That's something to check. But now we have this data analysis tool pack that was not here before, I promise. I really should have shown that to you, but that's okay. You might want to show that to them. You may not want to, right? This is all about just showing things that they can do in Excel, right? So let's say, for example, now that we're here, let's click data analysis and let's build a histogram of birth year, just because it's interesting. And so data analysis you can show comes with things like regression, t-test, moving average, but covariance. But the one that we're interested in, of course, is histogram. So we'll hit OK. The input range is going to be this range right here. We want to take a histogram of age or birth year. I said birth year before, but like age is fine. And then bin range is the interesting thing. If you leave it blank, it will automatically calculate bins for your histogram, which is to say it will take ages within a certain range from each other and put them into a single bar, right? As we will see right here when it creates this histogram, but it did not create the graph. Why didn't it create the graph? Oh no. Well, let me show you something interesting really quick, and it also does it in a separate sheet, which I think is funny. That didn't actually create a graph, which is a problem, but if we come back to histogram and click OK, and we keep the same input range, but we actually come down here to the bottom and click chart output, then it will, in fact, give you a graph. And that is something you could show them, for example, because the assignment asks them to create a histogram for something. This is a stats class after all. So you might want to show them, oh no, it didn't put out anything, right? You can also specify an output range here by just clicking so that it doesn't go onto a different sheet. But let's just go ahead really quick and make that. This histogram says, okay, we've got, looks like one person who is 18 or younger. We have what looks like 7 people who are 21 or younger, who are between 19 and 21. It looks like 4 or 5 people who are between 22 and 24, and so on and so forth. So that's how they make a histogram. And of course, because you've already shown them some graph options, they'll know that they can like change the title to something like, a really cool histogram, which may or may not, wink, be required on the assignment, right? That is actually everything, and the lights are killing me again. Other than to discuss one other thing, which is the idea of a file type. So what I'm going to do is I'm going to delete this histogram right here, and these over here I'm going to get rid of, right? That is everything for Excel except to talk about the difference between XLSX and CSV, which is to say I can file save as to some, I don't know. It gives me an option to save it as an Excel workbook, which will keep my graph alive. If I have a graph, it will keep the image there, and it will keep it all looking nice, like as if I'm just looking at Excel, right? I can open it really easily. But then the other really common data type file that we're going to talk about later in this class as well is the .csv, which basically just takes everything in every cell, and basically what a CSV would do, if I go back and I just take a look at this, what it would do is it would do age, comma, order, comma, number, comma, blank, comma, birth year, comma, and then it would have probably a bunch more blank commas, right? And then it would come down and it would hit enter, and it would do 21, comma, 1, comma, 1, comma, blank, comma, 2001, comma, right? It would just go across and separate everything by commas and enters, which is really nice because it's a really cheap way to store data, which is to say it doesn't take a lot of space. And so a lot of the files you get off the internet will be in CSV. And they will also play with CSV later in the Stata 1 and Stata 2 assignments as well, so no need to go too in-depth on it. But that is basically everything that we need to know, everything that we want them to know about Excel in order to give them the skills they would need to succeed with it in this class. They might want to use it in like a data analysis project or something like that. That is fine, but also the intro to the next lecture is me talking about how using Excel for those data analysis projects can be problematic. If, for example, you need to match up massive lists of stats for every county in the United States, it's like 3,000 observations at least, and it can get really tedious to do in Excel by hand, but in Stata, 3,000 observations is basically child's play. So that is sort of the propagandizing at work, if you will. That's everything for Nice to Sheet You. Again, we have links to the lecture notes, the assignment, the files for the assignment. All that stuff is at the GitHub link that's in my description. Also in the description is a link to teamorg.org that you can find. You can find all of this stuff there. It links you back to the YouTube, it all just sort of links to itself, right? So hopefully this has been helpful to you, and you've sort of got a sense of how maybe you would want to use these lecture notes and use your sort of discretion as a professor, of course, to teach Excel, the basics of Excel. And if you're a student using this for review for the homework, I hope that you find this helpful, right? This is sort of a dual purpose video to that end. So thank you so much for watching. If you have any questions, of course, send me an email, labhours@teamorg.org, or just leave a comment on the video. I will answer both of those things, not a problem. And feel free to use the lectures and stuff. I'm putting it out there for public, so no need to worry about permissions or anything like that. It's all here, right? If you have any questions, of course, you know where to put them. Be sure to leave a like, subscribe to the channel if you do use the lectures. That's actually what you have to pay to use the lectures, right? I'm just kidding. You don't actually have to pay anything, but I'd appreciate it. It's helpful. It helps people find the resources, right? So thank you so much for watching, of course. Have a wonderful time. We'll see you again next time in Lab Hours. The next lecture is the Stata 1 A Blind Date with Big Data lecture. It's actually already recorded. I'm recording this one after because I procrastinated this one a little bit, but totally fine. You can find that one in the same playlist this video is in, and then after that will also be the second Stata lecture in the same playlist. So thanks for watching. Have a wonderful day. Bye-bye.